Welcome to Functions Part 1. This video is for grade 10, 11, and 12. And of course, as you already know, this is the general formula that we use for our linear function. Y equals to mx plus c. And of course, the m represents the gradient or the slope. And if m is positive, then your graph will be upward sloping. And if m is negative, then your graph will be downward sloping. And if m is 0, then you will get a graph that's a horizontal line. Let's go on to the questions. Question 1. You've been asked to draw the graph of the linear function. All right, this is very easy. We can do this in two ways. The one way to do this is we could substitute points. Remember, so that is our function. So instead of x, we'll just put brackets there. All right, and we want to substitute different x values into the equation. If we substitute x equals to -2, then y will be equal to 10. And if we substitute x equals to -1, then y will be 8. And of course, if you substitute 0, you'll be left with 6. And I think we could see the pattern here. If you substitute 1 into the equation, y will be 4. If you substitute 2, then y will be 2. All right, and once you've determined those coordinates, you can plot them on the Cartesian plane. -2 and 10 is this point over here. All right, -1 and 8 is this point over here. 0 and 6, 1 and 4, 2 and 2, and of course, once you have determined all those coordinates, you can draw a line through them. So you draw a straight line through all those points, and that's the one way to work out your linear graph. The second way to do this would be to find your intercepts. All right, you find your y-intercept, you find your x-intercept. That's the second method you could use to sketch your graph. So let's look at the second method also. All right, the second method to use would be to find your y-intercept and your x-intercept. Okay, so to find your y-intercept, you need to make x equal to 0. So if we take our equation and we make x 0, then our y-intercept will be equals to 6. Okay, the x-intercept, you make y 0. And of course, if y is 0, that will be our equation. That's 6, 3. So those are intercepts. At y, the graph should cut the y-axis at 6. It should cut the x-axis at 3. Okay, so, all right, so we have a y-intercept at y equals to 6. We have the x-intercept at x equals to 3. And of course, we could draw a line through those points to determine our linear equation. So this is the second way in which you could sketch your linear graph. All right. For question 2 is just the reverse of question 1. In this question, the graph is given and you have to work out the equation. And of course, we know this is the format. Just get that right. This is the format of a linear equation, y equals to mx plus c. All right, and of course, we know that where the graph cuts the y-axis will be your c, your constant, when x is 0. So to work out the c, we just look at where the graph cuts the y-axis, and that point is at 7. All right, so we've got c is 7. Now we will determine m. And to determine m, we can actually substitute any coordinate point. Let's use this one. When x is 4 and y is 4. All right, so if we use that coordinate point, we can determine m. Okay. Cos for m will be -3. We divide both sides by 4. Then our m is -3/4. Therefore, our equation will be y. And we now know that m is equal to -3/4x. And we know that c is 7. So that is our linear equation. All right, let's move on to a parabola. All right, a parabola has this general formula. A equals ax squared plus q. All right, and of course the a will tell you if the graph will be facing upwards or downwards. If a is positive, then your graph will be facing up. But if a is negative, then the graph will be facing down. And of course the q tells you how the graph shifts. Okay, so let's go on to the questions. Again, you're given a parabola or a quadratic function equation, and you have to use it to determine the graph of a parabola. Okay, so let's look into that. And again, the one way to do this would be to substitute points. If that is our equation, all right, we can substitute points. Instead of x, we put brackets there, plus 4. All right, so if we substitute different points, again, let's start with -2. If x is -2, then y is 0. Okay, next point, x is -1. If x is -1, then y is 3. Okay, y is 3. Of course, if x is 0, then y is 4. That's obvious. All right. And if x is 1, then the y is 3. And finally, if x is 2, then the y value will once again be 0. Okay. And once we've substituted those values, we could of course plot the graph. All right, we've got a point at -2 and 0. That's a point there. We've got another point at -1 and 3. That's a point there. And we've got a point at 0 and 4. That's that point there. 1 and 3. 2 and 0. Okay, and of course, if you draw a smooth curve through those points, you will get the parabola, okay, of that function. Let me just try to do that a little better. Okay, so we're going to try to draw okay, That is, of course, the parabola of that function. And of course, if you wanted to do it a different way, we could have looked at it like this, to say our x function, if negative, would look like this. And the positive 4 indicates that we are shifting this function up by 4 units. So 1, 2, 3, 4. So at 4 is where our new graph will be. So that would be in a different way to look at it. Okay, so let's move on. How do we then find the equation of the shifted parabola below? Okay, and of course, we know that the general formula for our parabola is ax squared plus q, where q represents the shift, and we could see that this graph is shifted up by 2 units. So that is our q, the 2, the upward shift. So q is 2. All right, and now we have to determine a. And to determine a, we could use any coordinate point on the graph. We can use this one, 2, x is 2 and y is 0. So if we use that point, okay, we can find a. Okay, and of course this is 2. 2 squared is 4a plus 2, and of course for a, if we take the 2 over, divide both sides by 4, and a will become negative a half. And of course, to write out our full equation using that general formula on top, y is equal to, we now know that a is negative a half, x squared plus q, and q we know is 2. So that is our equation for the parabola. All right, let's move on to the hyperbola. Now, the hyperbola will have its asymptote, or asymptotes at x equals to 0 and y equals to 0. That means it will not touch the x-intercept or the y-intercept unless it is shifted. Okay? And this is our general formula for the hyperbola. And of course, the value of k will determine whether we have a positive hyperbola or a negative hyperbola. If k is positive, then the hyperbola will be in the first quadrant and it will also be in the third quadrant. But if k is negative, then our hyperbola will be in the second quadrant and also in the fourth quadrant. So let's go to the questions. Draw the graph of the hyperbola. Okay, and again, we could do this by substituting points. We don't need a calculator for this. 4 divided by negative 2. So if x is negative 2, 4 divided by negative 2 will give you negative 2. 4 divided by negative 1 will give you negative 4. 4 divided by 0, you cannot divide a number by 0. There's no solution there. That's where we have the asymptote. Okay, and of course, 4 divided by 1 is 4, and 4 divided by 2 is 2. All right, so let's plot those points. On the Cartesian plane, we've got negative 2 and negative 2, and that's that point there. Okay. We've got negative 1 and negative 4. That's the point over there. Okay, that's the point over there. All right, and if we come to the right-hand side, we've got 1 and 4. That would be the point there. 1 and 4. Okay, and we have 2 and 2, which should be the point over there. Okay, 2 and 2. All right, and once we've plotted those points, we could draw our hyperbola graph. Okay, through those points, they give us a general direction of how our hyperbola should look. Let's try to draw a curve to those points. Okay, remember it will never touch the x-axis and it will also not touch the y-axis. We do the same thing in the third quadrant. Okay, and just remember the graph of the k was positive. That's why our graphs are in the first and the third quadrant. Okay, that will be the graph of that function. Let's move on to the next question. All right. The value of k is now negative, so we know we're going to have our hyperbola in the second and the fourth quadrant. But there's also been a shift. All right, remember our asymptote is always at the x-intercept and always at the y-intercept. But the y-intercept has shifted up by 2 units. So if there's a shift, then we need to draw a dotted line, which will be our new asymptote. And the shift was only to 1 by 1 unit. So we've got an asymptote now at 1, no longer at 0, but at y equals to 1. Okay, and of course we could substitute points to determine our y values. Okay, negative 4 over x plus 1. Okay, so let's try out different values. If x is negative 2, then y will be 3. Okay, if x is negative 1, then y will be 5. And again, if we take negative 4 and divide by 0, there's no solution. Cannot divide any number by 0. Okay, and if we substitute 1, x equals to 1 will give us negative 3. If we substitute 2, then we get negative 1. And now we can plot the graph. Negative 2 and 3 is over here. Negative 2 and positive 3 over there. And negative 1 and positive 5 is over there. Okay, we can then draw a line through those points. Okay, let's go to the right hand side. We've got 1 and negative 3 over there. 2 and negative 1 is over there. And of course, we can now draw a curve through those points. So remember now the asymptote is at 1. So the graph does cut the x-intercept, but it cannot touch 1. Okay, because the asymptote is at 1. So that would be the graph for that function. Okay. Finally, we look at the exponential graph. The exponential graph, very simple. That's the format of the exponential graph, and of course, the b will tell us if the graph is upward sloping or downward sloping. If b is positive, the graph will be upward sloping. But if b is negative, the graph will be downward sloping. Let's go to the question. All right. You're being asked to draw the graph of the exponential equation. And of course, going back to our formula, forgot to mention the Q. The Q would once again represent a shift. Okay, if there's a shift, that shift will be indicated by Q. All right, the exponential graph also has an asymptote at y equals to 0, right? But for this graph, there's been a shift, and the shift, the asymptote is now being shifted to 2. And again, in this case, you would draw a dotted line at 2 to indicate that we've got an asymptote at 2, because the shift, the Q is 2. So once you've determined your new asymptote, you may now substitute different points into the equation. So we have an equation of 2x, so 2 to the x plus 2. So let's substitute different values starting with -1. -1 will give us 2.5. Okay, so -1 will give us 2.5. Substitute 0. 0 will give us 3. Okay, when x is 0, y is 3. So that would be the point on the y-axis where the graph cuts the y-axis. Of course, 2 to the power of 0 is 1, and 1 plus 2 is 3. That's how we get the 3 there. And if we substitute 1, we get a value of 4. If we substitute 2, we get a value of 6. Alright, so let's plot those coordinate points. X is -1, y is 2.5. That would be point over there. Okay, x is 0, y is 3. So that point was over there. Let's try to get that right. -1 and 2.5, it's between 2 and 3. It's that point over there. Okay, and x is equal to 0 and 3. Okay, 1 and 4. Be that point there. 2 and 6. These points keep disappearing on me. So we've got 1 and 4. You've got 2 and 6. All right, so we know we have an asymptote. It would be at 0, but because of the shift, we have an asymptote at. So your graph can never touch 2. So that would be the graph of the exponential function there. Okay, it's upward sloping because, as you can see, that the b is positive. If let's say the b would have been a negative value like 2 to the -1, right, which of course we can write as 1 over 2x, then your graph would have been downward sloping that way. All right, this is the end of functions. Of course, there's part 2 for grade 11s and 12. Look out for that part, and thank you.